that we were doing yesterday. The question that we were doing yesterday, whereby we're given in the figure QS and PR are the diameters of the circle with center O, such that PR is parallel to PQ is parallel to SR, and then PS is produced to T. N is a point on the circle such that Q1 is equal to Q2. Sn is drawn. RS intersect Qn at M. And we're also given that QS1 is 48. Yesterday we did manage to answer the first question that was saying calculate the size of Q1. We said Q1 is equal to 24, but we started by saying S1 is equals to the whole of angle Q. Why the whole of angle Q? Because S1 is the exterior angle on the cyclic quad. The cyclic quad, which I highlighted in green. S1 is the exterior angle. And then from this statement what we're given here, we are told that Q1 and Q2 they are equal. If Q1 and Q2 are equal and the whole of Q is 48, then we divide 48 by 2, then we got 24. That is why we say Q1 is equals to 24. We also found angle R. Angle R. We said angle R is 24 because of the angles in the same segment. If you check what I highlighted with a pink, I think it's pink this color. With pink, then you can see that is that butterfly theorem number 4, that says arc subtends equal angles, or angles in the same segment are equal. So we can agree to say Q1 and R are equal. Q1 and R are equal. And the next question was saying calculate the size of angle M1. Calculate the size of angle M1. Okay. Can someone guide me, please? Calculating the size of angle M1. M1, I'm listening.
48, sir.
M1 will be 48. How did you come to 48?
M1 lingana no Q, corresponding angles.
Okay. Let me do that. I didn't see. Okay, let me increase the size of the pen. This line is parallel to this line, we're told. And you're saying, now I see. So because those two lines are parallel, then you are saying that this angle, which is 48, is equal to this angle. It's also 48. That's what you're saying. Is that what you're saying? Okay. So my girl here is saying M1 is equals to 48 degrees, and reason is the corresponding angles. And then every time you write it corresponding, alternate, and co-interior, we need to mention the parallel lines. So the parallel lines at PQ is parallel to SR. PQ is parallel to SR. Okay. Do we have any question there? Any comment? Any question? No question. Okay. Let's move on to this one. Prove that ST is a tangent. Prove that ST is a tangent to the circle passing through M and S. So they are saying there's another circle, M and S. So what I usually advise learners to do, draw that circle. The circle that they're talking about, draw it, passing through those points. We're passing through M, we're passing through N, we're also passing through S. So we've got M and S. Yeah, to me it looks like a circle, by the way. I don't know to you guys. To me it looks like a circle. So They're saying that we must prove that this line is a tangent. This line is a tangent. So, inside the drawing, if I may ask, inside the drawing there, do we see this one, that is number one, or do we see this one, that is number two? I'm talking about tangent, sorry for that one. Or do we see this one? Which one do we see? The first one, the second one, or the third one? The first one is tangent perpendicular to the radius. Second one, tangents from the same point. The third one, tan chord theorem. Which one do we see inside the circle?
So it's tan chord theorem.
Okay. If we are seeing the tan chord theorem, it means, can I change the color of the pen so that we can see what I'm emphasizing on? Okay. It means we can agree to say that is the triangle that we are referring to, that is talking about the tan chord theorem, meaning this is the tangent and this is the chord. So the angle between a tangent and a chord must be equals to the angle in the alternate segment. Mind you, this thing is not a tangent, but we want it to be a tangent. But if we check, we know this angle is 48. And we also know that this angle is 48. Am I right? 48 degrees, not 480, sorry. Now that we know that, okay, next time what you do, you draw the circle around the point that they're talking about, and then check which one do you see. Do you see the first one? Do you see the second one? Do you see the third one? The one that you see is the one that you're going to use to prove that you've got a tangent. That is the one you're going to use to prove that you've got a tangent. So, in this case, we've got S1 being equal to M1. What is the reason that S1 is equal to M1? S1 is equals to M1, which is equals to 48 degrees. The reason is what?
Tan chord, sir.
Tan chord. Now, I usually advise learners to say, if they are saying prove that this is a cyclic quad, you must never use cyclic quad as your reason. You must conclude with cyclic quad. If they say prove that this is a tangent, you must never use tangent as your reason. You can only use tangent as a conclusion. So, to talk based my fact on what you just said there, the reason would be proved. I have proved that those two angles are equal because I am given S1, but I've proved M1 that it's 48. So I've proved that those two angles are equal. I've proved that those two angles are equal. Since those two angles are equal, my conclusion can be, now I see a tan chord theorem. So I can conclude to say ST is a tangent. Is a tangent. Why am I saying it's a tangent? Because of the converse of tan chord theorem. Converse of tan chord theorem. Sorry for the writings there, guys. I can see that I'm messing up, so to avoid that, let me write clearly. Converse of tan chord theorem. Okay. Converse of tan chord theorem. That is my reason that is making me to conclude that ST is a tangent. Now, in case there was a question below this one, in case there was a question below this one that requires you to use the tan chord theorem, then your reason you wouldn't say converse, you are going to say tan chord theorem. Why? You have proved that ST is a tangent. Just in case, next time remember that. You cannot use the reason tan chord theorem any question above. You can only use the reason tan chord theorem every question below if you are looking at ST. I hope I'm making sense so that you guys can know. Can I move on? Do we have a question? Okay, no question. Since there is no question, let's move on to this one. They are saying, let's make sure that it's very clear to everyone. Can we all see the question in the diagram below? Can we all see that statement?
Yes, sir.
Okay, in the diagram below, BOC is a diameter. BOC is a diameter. And then now that theorem that is talking about the diameter, this theorem here, it must automatically come into your head. This theorem here, it must automatically come into your head. I'm not saying it is there, but maybe you can find it is there. That angle is 90 degrees. And then AP is a tangent to the circle at A. AP is a tangent, that is AP there. That is a tangent at A, we can see that. And we're also told that AE is equals to EC. AE is equals to EC. We don't know how is that going to help us, but we're told that. Okay. And again, just by looking, I don't usually say understand by looking. We are told that this line is a tangent. And there's a dot there. Basically, that dot would say it's a center. That is how I understand it. I believe my people will also understand it that way. Then we've got the center then. Immediately you've got the center. Or automatically your head must also bring up this theorem. This theorem must also come into your head because of the center there. Oh, okay, I'm drawing the wrong thing. Sorry for that, guys. It's not a radius. It's there's this chord, and then there is that. Automatically, this theorem must come into your head. Even this one, either this or this one, or even the other one, any of them. If any of them they are there, we touch there, and then we touch there, we touch there, and then we touch there. Any of those, any. So all those theorems must be in your head. I'm not saying they are there, but I'm saying watch out. They can help you because of those specific weights. Because of those specific weights, circle is the diameter and the center. Even though there's no word center, but we can see that O is the center there. Now, we can try to analyze and look what we're looking, see anything that we're looking for here. Am I right if I'm saying that angle there is 90 degrees? Am I right?
Yes, sir.
What will be the reason?
The reason is the angle of the semicircle is equal to 90 degrees.
Okay, can I do it like this? There is this one. There is this one. I know that every one of you can see that. There is this one. Now, myself, I'm referring to this one. This one. What would be the reason that angle there is 90?
It was a tan radius, sir.
Tangent is perpendicular. Can you say it like that next time? Tangent is perpendicular to the radius because this is a tangent and this is a radius. Tangent is perpendicular to the radius. Okay. Now, I heard people talking. Are you talking about this one? You guys were saying, we saying what is the reason there?
The angle of the semicircle is equals to 90.
The angle in the semicircle is equals to 90 degrees. The angle in the semicircle is equals to 90 degrees. Now, if I am told that this line, which is a chord, is bisected, this line is bisected because this side is equals to this side, what does it tell you about these two angles here? Anyone? I'm told, if you check, you are told that AE is equals to EC. AE is equals to EC. That's what you're told. So then what can you say about angle E1 and angle E2? Each equals to 90 degrees. Thank you for that. And then what is going to be the reason? What would be the reason? Yes, I agree. The angle. Hello?
Sir,
Yes?
so it's line drawn from the center to the chord bisects the chord.
Okay. But yes, I agree with that. But I would prefer you to say the converse of perpendicular line from the center. I would prefer you to say that. Converse of perpendicular line from the center. But even what you're saying is also correct. Okay. Now, I'm trying to guide someone here. Now, if we know that that angle is 90 because of the reason that you guys gave me, and we also know that that angle is also 90, what would you say about these two lines, this line and this line? What did you say about those lines?
They are parallel.
Thank you. And what is going to be your reason? Yes, you're going to say they are parallel, I agree, but what is going to be your reason? Anyone? Anyone? What is the reason? Corresponding angles are equal. This angle is corresponding with this angle. Remember what I said about Bomakwapeni?
Okay, corresponding angles.
Yes, corresponding angles are equal. Okay, so just in case they say proof. What else? If I can say this angle here is x, if I say this angle here is x, do we have any other angle that might be equals to x? Okay, let's say we did prove that those two lines are parallel and we conclude that the two lines are parallel. Now, which other angle do you think is going to be equals to x?
Isn't it B?
B will be equals to x, and your reason would be? What will be the reason that B is equals to x? Let's say I agree. Hello?
Sir, I forgot the reason. Theorem 9 said the angle between a tangent and a chord.
Tan chord. The angle between a tangent and a chord is equal to the angle in the alternate segment. Tan chord. So you are saying B will be x because of the tan chord theorem. That's what you are saying. I believe people do agree. Yes. Let me just show for someone who might be behind and not understanding what's going on here. If I do that, and then I also go that way, and I also go that way, and then there is a tangent there. That is what we're referring to, tan chord theorem. Okay. Any other angle that is equals to x based on what we're looking at? Any other angle that is equals to x? Do we see?
Can't you say
I'm not sure if you're still talking.
O1?
O1 would be equals to x. What would be your reason? Can I hear the reason? Why would O1 be equals to x?
So I'm saying O2 sir, and O1 sir, equal to X.
O2 and O1 are each equal to x. Is that what you're saying?
Yes, like so those two and say that equals to X. There is a turn code.
Remember, turn chord, it must touch the circle 3 times. So if I start at A, where must I go?
9 sir.
Okay, so she's saying she's scrapping that one off. Yes, I heard the voice of a male there. Who's that? Can you please talk to us? I agree with O1 is X. Which? Yes?
So I wanted to say angles in the same segment, but I noticed that it doesn't touch the circle 4 times.
Okay, but if we are saying these two lines are parallel, then it means they are forming the letter. Can you all see that? They are forming the letter Antoni, that one. Can you all see that? The letter F. Then boma kwapeni na likwapa, na lelinyi kwapa. Then boma kwapeni bayalinga. The armpits. Okay, so that's why I'm saying I agree that that angle is x. Which other angle is equals to x? Anyone? Remember, this is a radius and also this is a radius. Remember that. And the radius are equal. So what would we say about A3? If B is x, then what about A3? A3 will also be x. What is the reason that A3 is x? What is the reason that A3 is x?
Oh, X.
Yes, I want the reason. Why do we say A3 is x?
Isn't it equal chords, equal
Angles opposite equal sides. Angles opposite equal sides. Yes. Will I be right if I'm saying this angle here also is x? I just want to check on that one. Will I be right if I'm saying that angle there is x?
Yes sir.
And then if I am right, what would be the reason? Remember, your answer is not
that?
your answer is not right, your answer is not wrong. Oh wow, I missed that one. Wow, okay, I missed that one. Myself, I was seeing the exterior angle of you see, now it's nice to have these classes. I missed that one. She is saying z uz u uz. Okay, she's saying that, then I'm gonna go like that, then I'm gonna go like that. I missed that one. Myself, I was not seeing that. I was only seeing the exterior angle of a triangle, because this is x, this is x, and this is x. Automatically this one becomes x. Okay, but I agree with the alternate angles. I agree with that. Thank you for that. Now, I was just trying to help you to analyze whatever that is here, just to answer the questions that are coming after this one. Maybe they can end up saying cyclic quad. They can. Okay, let's just go straight to the questions. Okay, we go to the questions now. We're just analyzing.
Can I ask?
That. Yes, please.
So isn't C1 also is equal to X?
C1 equals to X. Okay, remember, let me say, we said that is X, we said that is X, we said that is X, and then we said that one is X, and then we said that one also is X. You are saying C1 would be X, and what would be the reason?
Say I see a cyclic quad, so coincident angles of a cyclic quad are supplementary.
Cyclic quad, it must touch the circle 4 times. So if I have to touch the circle 4 times, where do I start?
Oh, say never mind, D is outside the circle.
Okay, thank you. what I was going to agree on is that this angle here is 90 minus x, because the whole of this angle is 90. So this piece would be 90, and this side equals to this side. It means this I can agree to 90 minus x. That is what I can agree to, 90 minus x. Okay.
Okay.
Now let's move on. Remember, the x was not there. I just put so that all of us can manage to be able to analyze. Now that we did analyze, let's answer this question. Prove that BA is parallel to OD. Prove that BA is parallel to OD. The very same lines that we're talking about. For 4 marks, they're saying we must prove that those two lines are parallel. We must prove. So, what would be my first step? We must prove that this line here is parallel to this line here. What would be my first step to get all those 4 marks? Anyone? Okay, because of time, I'm gonna say angle BAC is equals to 90 degrees. Why is angle BAC equals to 90 degrees?
Angles in the semicircle
Angle
is equals to 9.
in the semicircle. Okay, and then also angle E2 will also be equals to 90. What is the reason that B2 is 90? I mean E2, sorry, did I say B2? E2.
Angle center bisects the chord.
Okay, let's say converse of perpendicular line from center. Converse of perpendicular line from center. Okay, then we can see that they are forming the letter F there. So we agree that this angle is 90, and then that angle there, obviously that one is 90 then. Okay, then the conclusion would be therefore AB is parallel to OD, and our reason is what? The corresponding angles are equal. That is the reason there. Then we get our 4 marks. Any question?
Will I be wrong, sir, go E2 for saying what I said, sir?
Can you repeat the statement? What did you say?
Sir, I said angle drawn from a center bisects the chord, sir. Will I be wrong to say that, sir?
Line drawn from the center to the chord bisect the chord.
Will I be wrong for saying that?
There's this other reasons that they used to accept, but my thinking is you're not wrong, because the chord is bisected. Why am I saying use converse? Because now we say the perpendicular line from the center bisect the chord, but this time we start with the chord that is bisected. We are not starting with the perpendicular. So because we start with the chord that is bisected, that is why I'm saying let's use the converse of the perpendicular line from the center. Can I pass? Yes, no? I'm not hearing yes.
Sir.
Okay, thank you. Okay, we have to prove that AOCD is a cyclic quadrilateral. It's a cyclic quadrilateral. Now, if we have to prove that that is a cyclic quadrilateral, we need to draw, remember we've proved that those two lines are parallel. Let's remember that, ne? let's just indicate that we've proved that these two lines are parallel. If we can use parallel lines, now we can use parallel lines. Now they are saying we must prove that A, O, C, D. So I must draw around those points. I must draw a circle. Why? They said it's a cyclic quad. So a cyclic quad is a quadrilateral inside the circle. So now we can do that. Okay. Now inside that thing there, we need to check. Do we see sorry for the drawings there. Do we see this one? Or do we see this one? Or do we see this one? Which one do we see inside that drawing there? Which one do we see?
The first one.
The first one is there.
Both. And the second one, sir.
Even
And
the
the third
third
one.
even the third one. All of them, actually all of them are there, right? So let's just work with the one that can help us. Let's just work with the one that...
Even though D is outside the circle.
Can you repeat that, please?
Say even though D is outside the circle.
Yes, yes. In this case, remember, they didn't draw the circle for you. You are the one who have drawn the circle for yourself. So if you can prove that this angle here is equals to this angle here, if you can prove that those two angles are equal, done. You are correct. Everything is right. But you need to use the correct mathematical reasons. That why do you say this angle? Or maybe even if you can prove that this angle here, C3, is equals to the whole of this angle here. If you can prove that that angle there is equal to that angle there, done. Then it means what you are saying is true. That will be the exterior angle of a cyclic quad. And again, based on that, again, if you can prove that this angle here plus this angle here, they give you 180 degrees, done. You are 100% done, because they're supplementary. Or if you can prove that this angle here plus this angle here, they give you 180, then you are done. Okay. Or I started with the last one, I followed by the second one. I explained this, right? I explained this. Now I'm on this one now. If we can get that this angle here and this angle here are equal, right? Or the other side, this angle here and this angle here are equal. If we use the other one, if we can prove, I'm just showing you, I hope someone is already seeing something there. If we can prove that this angle here and this angle here are equal, or this angle here and that angle there are equal, then it means we are done. So since we said all of these things they are there, we said all these things are there, then let's try to look for the one that can work for us. Which one can work for us? Which one is working?
708, sir.
Can you please repeat that?
708 ne?
Yes.
Because phayana ku-A ne, angithi khona u-tan perpendicular to radi
Yes.
to i-radius, so 90 lona ne.
Yes, there is 90 here.
Then
Yes.
ke ngoku la A uyalingana no-C3.
No, C3 njani?
Yes.
Yes.
I-exterior angle of a cyclic quad equal to opposite interior angle.
I want to agree, but since we know that one is 90 and we know the reason, why do we say this is 90 also? What would be the reason that this is 90?
Alale ngisho yokuba i-exterior angle of a cyclic quad iyalingana ne-opposite interior angle.
Oh, okay. Remember, by the way, this is not a cyclic quad yet. Ne? Yes. Thank you for that. I wanted the reason. It's not a cyclic quad yet. So I agree with what you are saying, but now the problem is your reason is cyclic quad, and this thing is not a cyclic quad yet. So can I scrap that reason? Maybe another reason that can work. I don't know. Unless if we can find, using all our mathematical reasons, if we can find that this angle is 90, then we can conclude to say the exterior is equal to the opposite interior. But we need to get this one. We know that this is 90, y tangent perpendicular to the radius, but we didn't get this is 90. If we can get this is 90, our conclusion would be what you are saying. Okay. Someone talk to me. I'm still here.
Okay, since u-A sithe ngu-90 ne?
Yes.
Then what about C1 plus 2 ngu-90 naye because opposite ne?
Yes, they are opposite, but remember, if you are going to say your reason is opposite angles of a cyclic quad, then it's not a cyclic quad yet. I agree with what you're saying. Why would C1 and C2 be equals to 90? If we can get that one, I'm sorted. I'm okay. Anyone else? She's trying here, guys. Let's just not be quiet, all of us. Try to say something. I'm listening. It's not the only thing, by the way. All of those, we found that they are equal. All of those theorems, we found that they can work, all of them. Anyone?
So,
Yes, please.
Can't we equate A2 with B2 as the angles in the same segment are equal?
A2 with what?
D2.
A2 with D2. What is the size of angle A2? What is the size of angle D2?
A2 is 90 degrees.
A2 is 90 minus A1. A2 is 90 minus A1. That is what we have there. 90 minus A1. Because we know that A2 plus A1 is 90. So A2 would be 90 minus A1. So if A2 is 90 minus A1, then what would be the size of D2, sorry. Okay?
Wouldn't it be D2
Yes.
90 minus sorry sir, can you repeat the A2 one?
I was saying we know that the whole of this angle is 90. So if I want this piece, I must say 90 minus this piece. That means my A2 would be 90 minus A1. So I want to know what A2 yena sizomthola kanjani. What would be A2? Is it still going to be 90 minus A1? And what would be the reason? That's what I'm saying.
Wouldn't it be the angles in the same segment have to be equal?
If we use the angles in the same segment, it's because it's a cyclic quad, but it's not a cyclic quad yet. So we can't use the cyclic quad as a reason. Okay, can we do it like this? Let's try it like this. There's another way I'm seeing, but another way that I'm seeing. Let's just use this one. We said when we started, I put X there on A1, and then we agreed to say A1 is equals to B. We agreed on that one, and we said the reason is tan chord, the angle between a tangent and a chord. So if this angle here is equals to this angle here, and we've proved that the two lines are parallel, then we also said since even the two lines are parallel, then it means we can still say, okay, that means O1 is also equals to B. And what is the reason that O1 is equals to B? Then it means the reason would be the corresponding angles. And we mentioned the parallel lines. AB is parallel to OD. And then from here, now that we know that A1 is equals to B and even O1 is equals to B, it means that A1 is equals to O1. Just based on that statement, we are saying A1 is equals to B. We are also saying O1 is also equals to B. That means A1 and O1 are equal. Then if A1 and O1 are equal, A1 is equals to O1 and A1 are equal, then we can conclude to say this thing is a cyclic quad. Therefore, AOCD is a cyclic quadrilateral. And why do you say it's a cyclic quadrilateral? That is the converse of angles in the same segment. Angles in the same segment. Angles in the same segment. Converse of the angles in the same segment. Just to make sure that everyone else understands. Are we still there, by the way? Are we still there? Can you still hear me?
Yes.
Okay. If I go that way, and I go that way, and I go that way, and I go that way, I believe people can see what I'm talking about now. Any question if we have? I might be slow, but my aim is for you to understand what I'm saying. I'm trying by all means to be slow and ask all those questions so that we can try to remove everything that is not right in what you are saying, so that when you are alone in the exam or practicing, you should remember the questions that I was asking and the suggestions that I was giving, so that how to answer. Do we have any question there? No question. I think I did put another question here. Oh, it's there. Oh, I thought it's not there. Okay. Do we have how many minutes are we remaining with?
10 minutes.
Wow, 10 minutes. If we're left with 10 minutes, then let's just analyze that. In the diagram, ST and VT are tangents. We can look at the diagram there, and then ST and VT. Okay. By the way, this thing, can I just try to reduce the screen so that everyone can see? Your microphone, please. Thank you. Okay, this means this thing is a circle, guys. I don't know how it was cut off. So it's a circle. They're saying ST, we can see ST, and VT, we can also see VT is a tangent. All the tangents theorem, let them come into your head. All the tangents theorems. Okay. R is a point on the circle. R. Do we have R there? Yes, we do have R. R is a point on the circle. So it means this point is R here. That is the point that was cut off. That point there is R. R is a point on the circle. And W is a chord. Is a point on the chord. Okay, W is a point on the chord RS. We can see that. Such that WT is parallel to RV. WT is parallel to RV. They've shown us the parallel lines there. I believe everyone can see that. SV and WV are drawn, and then WT intersect SV at K, and they say let S2 be equals to X, and luckily they've written that for us. They said S2 is equals to X. We can see that this is X. S2 is equals to X. Before we answer the questions, in the meantime, do we have any other angle that might be equal to X?
Yes.
Okay,
Yes,
which angle?
V3.
V3. What would be the reason that V3 is X?
tangents drawn from outside the circle.
Okay, tangents drawn from the same point are equal in length, or we can say angles opposite equal sides. Angles opposite equal sides. I agree with that. What other angle equals to X? Talk to me. Do we agree that we've got
W,
which W?
W2.
W2 is equals to X, and what is the reason?
Angles subtended by the same segment, if I'm not mistaken.
Angles. Oh, are you talking about the angles in the same segment?
Yes.
Are you saying that because you are talking about WVST? Are you saying that?
Yes, sir.
Remember, that is not a cyclic quad. So I can't agree because T is outside. So I can't agree with W. But I can
Go
agree.
R, sir.
Hello?
Go R, sir.
R, yes, R. And then what is the reason for R?
Gun code.
Thank you. And if I'm not wrong, if you check the letter F starting at V, R, W, S, and then we join with WT, they are forming F. So it means this angle will also be equals to X. Am I right?
Yes.
Okay. Now, do we have any other that is equals to X? I don't know. I'm trying to look. I can't see. Okay. What is the first question? Oh, the first. How many minutes are we remaining with, guys?
5 minutes.
Okay, 5 minutes, but I'm gonna cut it off because I've got a grade 10 class. Now they are saying write down. Can I just try to minimize the screen again so that everyone can see? Write down with reasons 3 other angles that are equals to X, and we did find the 3 angles that are equals to X. The first one will be V3, and the reason is angles opposite equal side. The other one will be R, it is tan chord theorem. The other one will be W3, that is corresponding angles. Let's try to end with something like this one. Prove that WSTV is a cyclic quad. I'm sorry that I'm not writing. So we guys need to remember what I said. You draw a circle around those points that they're talking about. They are saying prove that this is a cyclic quad. This thing is a cyclic quad. And it's how many marks? The marks matters, 2 marks. They are saying 2 marks because they know you know the answer. The answer is looking at you.
So can we say W2 is equals to, I don't know, the upper. So
Okay, yes.
yeah, so can we say W2 is equals to S2? There is an angles in the same sec.
Okay, can we use what we already have? Can we use this one? Let's use what we already have. That one we already have.
And also, sir, V2 is equals to S2.
V
2 is equals to S2, sir.
Okay, the reason I'm saying, I'm hearing you, I understand you. The reason I'm saying let's use what we have. We have proved that this is this is x, and this is x. So we just take that and then conclude. So V3 is equals to W3, and then the reason proved. Then from there you can conclude. Therefore, SWVT is a cyclic quad. Reason converse of angles in the same segment. Guys, I'm gonna cut it off here because of time. I know that if I can continue, this thing is gonna cut me off while I'm still talking. To avoid that, so I'm gonna cut it off here, and then I'm gonna continue with this on Monday. Some of you will be invited, some of you will not be invited. If you want to check this lesson, go to my Facebook at Peruza Rapulana, or I'll send the link for YouTube also, that you guys can go and check. Here is the other questions based on that question that we're doing there. Then I'm done, and bye bye. Thank you, guys. Till we meet Monday. Yeah, even on Facebook there, I'm out. Let me just try to minimize the screen so that everyone can see almost everything that we were sharing there on the screen.
Sam,
Yes, my girl.
if like zininzi ezikufacebook and zimbalwa ku-youtube ngicela uzame ukumuva ziye ku-youtube zibe ninzi kwelaa cala because ku-youtube uyakwazi uba uzibukele naxa ungenadatha uzisave. Kufacebook kunyanzeleka ube nedatha okoko xa ufuna ukuzibheka.
Okay, I'll try that, but it means then I'll have to use the last year videos that I had. I have from there, but I'll do that. I'll do so. Okay, thank you. And I'm hello.
Alright,
Okay, thank you. Yeah.